Hi everyone, my name is Yu. I'm from Bowling Green State University. Welcome to Bowling Green. The title of my presentation is How to Lie with Maps. And the title is actually borrowed from a book. And the book is about 30 years ago. And at that time, it was a very, very popular book. The basic concept of this book is that the author tried to emphasize that when we make the map, and we sometimes have to apply the white lies. So in that way, you can make your maps function better here. And for me, I think that the lie is a little bit a strong word, probably British humor. And I think the cope probably is a better word here. Here's an example of how can we cope with a map. So this is a typical coral place map. And as we know that if for the coral place map, if we have same data set, but if you apply with different classification method, if you use different number of the classes, and then your map will look very, very different in terms of the pattern. This, for example, is a classification based on equal intervals. And this one is example of the natural breaks. And you can see that the pattern is really different. But today I want to compare the differences in terms of the hotspot analysis. And as you know, the hotspot analysis is a very kind of hot now in the GIS, in the analysis here. And epidemiology, for example, they use hotspot analysis. You can, constantly see the maps on the TV now in this epidemic times here. And hotspot analysis is basically based upon the GI star index, and the calculation is based upon this formula, and it's about a 1970s formula here. And the difference between the GI star map and the coral place map is that the coral place map, we only look at the unit itself, a county, for example, a state, for example. But if you use a GI star, and you have to look at the neighboring, and based upon your neighbor, and then you do the statistics calculation here. So it's more scientific oriented in that way here. And when you use a hotspot analysis, and you basically calculate the z-score. And if there are some area, z-score is too large to be considering as random, and then those places probably are special. Here is the slides simply show you the hotspot analysis in ArcGIS, and it was implemented in ArcGIS for a while here. So hotspot analysis is basically based upon their normal distribution. And if you're located in this middle area and you're considering as a random, but if the z-score is very large in the positive side, and that area is considering as a hotspot. If z-score is large in the negative side, and then that is considering as the cold spots here. In ArcGIS, it will actually generate a specific attribute table for you after you run the hotspot analysis. In that table, it will have specific z-score values and p-value and the number of the neighbors and a GI bin. Also, the ArcGIS can actually automatically generate the map with the special symbology here. So it normally will use cold color as a cold spot. It will use a red color as the hot spot here. Now, this is the basic idea of hotspot. And I'm interested in analysis of the elderly population. So I try to use hotspot analysis to analyze the elderly population. Now, this is an example of the Ohio. So if you look at this coral place map, and based upon the BG, which is a black group, and then probably you don't see very interesting spatial pattern from here. But if you run a hotspot analysis, so you have the input of each class with elderly population, and then you select a specific field, and then ArcGIS will generate a new feature class with you based upon the hotspot analysis. So here's the result. So if you look at that, you can see the huge difference in terms of the spatial pattern. So in this specific map, you will see that the cold spots are normally in the inner city. And then the hot spot for the elderly population, and it will display the rain pattern here. This, for example, is the Cleveland, and this is Akron, and this one is the Toledo, and this is Dayton, and this one is the Columbus here. And Cincinnati is a little bit different because Cincinnati also has a lot of the people living in the Kentucky here. So those are the elderly population in Ohio. Based upon the hotspot analysis, you can see the clear rim pattern in the urban area. Now, how about Michigan, right? So we can also run with Michigan, and this one is a coral place map. And the same thing, it doesn't the same see the spatial patterns here. And then after run a hotspot analysis, all based upon the default, and then here's the result. It's kind of disappointment. So if you look at this map, you will see that in the Michigan, you will see the large cold spot, which is based upon the Detroit. And then the other areas are the hot spot here. Now that seems not true based upon our common sense, because we know that normally in the city, you have the large elderly population surrounding the city here. Now, what is the problem? So the problem is actually comes from an optional parameter in hotspot analysis in ArcGIS. And there is an optional parameter, which is a distance band. Now, if there are very big differences in terms of the polygon size and also length of the polygon, and then the default probably will not pick up the spatial pattern for us here. So here you can see the differences in terms of the size of the census block group in the Ohio and also in the Michigan. You can see the big differences here. And also for the length of the BG, you also see the big differences here. So that means that for some place, if you run hotspot analysis, you really have to consider the parameter, which is optional, which is distance band here. So I added that optional parameter in the hotspot analysis for Michigan. I set for 2000, and then run the hotspot analysis. And here's the result. And it seems like from this map, you don't see much spatial pattern. But if you zoom that specifically into the urban area, and then you can see the similar rim pattern in the Michigan as the Ohio. So this is an example of the Detroit. And then you can see the rim hotspot around the Detroit. And this is Ann Arbor. And then again, you see the rim pattern around the city area. And this one is the Grand Rapids. And again, you can see that a cold spot in the inner city, and then the hot spot of the elderly population around the city here. Lansing, same thing. And this is for the Flint, and you can see that the rim pattern exists. And this one is Kalamazoo, and again, you can see those patterns here. Midland, rim pattern, and Bay City, rim patterns. And the places probably you don't see the rim patterns those are the areas which is the elderly population are dominant in those areas here. So what does this tells us? This tells us that if we run hotspot analysis, we need to co-op with that specific optional parameter, which is distance band. So here is my conclusion here. And hotspot is can tell us the spatial pattern because it is based on the spatial statistics here. Distance band is very important parameter in hotspot analysis. We need to considering that if you don't see the spatial pattern here. So for the Michigan, in the default hotspot analysis, we didn't find the spatial pattern as in the Ohio here. But if you change in the distance band, and then you will see that the rim pattern similar to Ohio occurs here. So because the spatial pattern of the elderly population is very important for the policy making, so I think that it is important for us to understand those spatial patterns here. That's my presentation. Hope you enjoy the conference at the BGSU. Thank you and see ya. Bye.